Hello and welcome to Chemistry 11. Today, we're going to learn about the irregularities within the concept of electron configuration and some examples to help us understand the topic a little bit better. The first example is chromium, with the chemical symbol of Cr. Since chromium has 24 electrons, if we were unaware of the irregularities, we'd think that chromium's electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. However, the d-sub level has more stability when it's half-filled or completely filled. In order to achieve this stability, one of the electrons in 4s2 will be moved to 3d5 so that the d-sub level is more stable. This would mean that chromium's correct electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, or AR 4s1, 3d5, where AR stands for argon. Additionally, let's get 3d5's quantum numbers. 3d5 is the 24th electron. With that information, we can say that n is equal to 3, l is equal to 2, and the sublevel is dumbbell shape, m sub l is positive 2, and m sub s is positive 1/2 spin up. The second example is copper, with the chemical symbol of Cu. Copper has 29 electrons. This would be the expected electron configuration. Using the first example's concept, one electron from 4s2 will be moved to 3d9 to achieve more stability. Copper's correct electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, or AR 4s1, 3d10, where AR stands for argon. Let's get 3d10's quantum numbers. 3d10 is a 29 electron. We can then figure out that n is equal to 3, l is equal to 2, and the sublevel is dumbbell shape. M sub l is positive 2, and m sub s is negative 1/2 spin down. The third example is silver, with the chemical symbol of Ag. Silver has 47 electrons. The expected electron configuration is this. The d sublevel is much more stable when it's completely filled or half filled, so we take one electron from 5s2 and is moved to 4d9 for the d sublevel to become more stable. Silver's correct electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d10, or Kr 5s1, 4d10, where Kr stands for krypton. Now, let's also get 4d10's quantum numbers. 4d10 is the 47th electron. This means that n is equal to 4, l is equal to 2, and the sublevel is dumbbell shape. M sub l is positive 2, and m sub s is negative 1/2 spin down. The fourth example is gold, with the chemical symbol of Au. Gold has 79 electrons. This is the expected electron configuration. The same idea from the previous examples applies here, so we'll get one electron from 6s2 and add it to 5d9. Gold's electron configuration would then be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s1, 4f14, 5d10, or xe, 6s1, 4f14, 5d10, where xe stands for xenon. Let's move on to 5d10's quantum numbers. 5d10 is the 79th electron, so n is equal to 5, l is equal to 2, the sublevel being dumbbell shape, m sub l is positive 2, and m sub s is negative 1/2 spin down. Our last example is palladium, with the chemical symbol of Pd. Palladium has 46 electrons. The expected electron configuration is this. Like the last examples, we'll give the d sublevel more stability by taking 2 electrons from 5s2 and adding it to 4d8. Palladium's actual electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10, or Kr 4d10, where Kr stands for krypton. In addition, let's get 4d10's quantum numbers. 4d10 is the 47th electron. This means that n is equal to 4, l is equal to 2, the sublevel is dumbbell shape, m sub l is positive 2, and m sub s is negative 1/2 spin down. That's all we've prepared for today. Thank you so much for listening, and we hope you've learned something.